Hey guys, good morning. Morning. What happened to you? Arey, am I audible to you? Can you please confirm the chat? Let's do that logistic regression. Linear regression is a regression technique. Linear regression is a regression technique. Logistic regression is a classification technique. Classification technique. Okay. Linear regression is a regression technique, but logistic regression is a classification technique. But we will see why the name is called regression term is there in the logistic regression. So that is an important thing. Let us assume that use case problem. You want to subscribe. You have a, suppose you are a magazine owner, some magazine, you have a magazine owner, and you want to know the subscription of your magazine based on age, based on age criteria. So you are a magazine owner. You want to know the subscription of the magazine based on the age criteria. So here the output, here the target column, target column is magazine subscription, and the input column is equal to your age. Input column is equal to age. Understood the question, right? You're a magazine owner, you want to know that subscription of your magazine based on the age criteria. So target column is equal to magazine subscription and input column is equal to age. It's look like this. Then age and magazine, suppose like this is there. It is a age column is there here and here magazine subscription. Magazine subscription is there here. Suppose age is equal to 30 years. The answer is might be yes. And age 35, the answer is no. And age 40, the answer is no. Suppose like this is there. This is your question. You are a magazine owner. You want to know that the subscription of your magazine based on age criteria. So here the target column is what? Magazine subscription. And the input column is age. Input column is age. బాగుంది నిన్న నీటి హరికృష్ణ ఎక్కడ అడ్రస్ చెప్తలేవు వెళ్ళి అవుదామంటే అడ్రస్ చెప్తలేవు టీ ఎక్కడ తెస్తున్నావు ఉందట ఎక్కడ? చలో. So logistic regression we are dealing ma, the use case we have written is called, suppose you are a magazine owner, you want to know that subscription of magazine is based on the age criteria. So the target column is the called magazine subscription and input column is equal to age. Now you don't know any classification problem, assume that you know only linear regression, and that is true only, right? You know only linear regression as of now. You don't know any other things, right? But just assume that. Assume that you know only linear regression. You doesn't know any classification methods. You doesn't know any classification methods. You know only linear regression. So based on your logic, what you will write? Subscription, subscribe equal to beta naught. You will write equation like this. Your output, this is y, subscribe, maximum subscribe equal to y. That y equal to maximum subscription equal to, you will write y equal to beta naught plus beta 1 into age. Here the y is nothing but subscribe. Y is equal to beta naught plus beta 1 into age. So because you know only linear regression, that's why based on the question, your mind is thinking like this. Subscribe is equal to beta naught plus beta 1 into age. But this is a wrong equation. Why it is wrong equation? Tell me. What is the problem in this? What is the problem in this equation number 1? What is the problem in this equation number 1? What is the drawback? What is the drawback in the equation number 1? Hello? Arun said correct. What about others? RHS. RHS is giving what? This RHS values always what? Always what? What is RHS values? Always numbers. Always what it is? Numbers. But what is your output? Categorical. That's why you can't applicable for classification problems as a regression equation. Understood now? Understood? Regression equation always give what? Numbers. But your subscribe is nothing but what? Subscribe is output is a classification, that is. Subscribe is nothing but yes or no. Yes or no. So that's why you can't equate that numbers with yes or no. So that's why this number one equation is a wrong equation. That's why we can't represent. That's why we can't represent classification problems, classification use cases, classification use cases with regression formula. With the regression formula. That clear? Can you please confirm the chat? So you based on the problem, before the linear regression, you doesn't know any classification problem. That's why based on your mindset, you provided subscribe equal to beta naught plus beta 1 h. But what is the drawback in this? This beta 1 plus beta 1 h, that is called RHS. RHS equation. RHS equation is giving always numbers, but your LHS equation is nothing but subscribe is nothing but yes or no. That's why numbers never equal to, that is yes or no. That's why you can't provide that classification problems as the regression problem. That's so that thing you need to explain. So you change your equation. You change your equation. Then your equation, you think like that, okay. Then instead of subscribe is yes or no. Yes or no. So I will not use subscribe directly. Subscribe directly. Then what you use? You use probability of subscribe. Instead of subscribe, what do you use, ma? Probability of subscribe. Probability of subscribe. P of subscribe is equal to beta naught plus beta 1 into h. This is equation number 2 you have written. This is equation number 2 you have written. Equation number 2. What is equation number 1? Subscribe equal to beta naught plus beta 1 h. Because I given the question age, I given the question answer subscribe. That is why. That is called subscribe here. The max and subscribe. Subscribe. And you know only linear regression equation. Then you have written subscribe equal to beta naught plus beta 1 into h. And then you realize that it is a wrong equation. Why it is a wrong equation? Beta 1 plus beta 1 h will give always a number. But subscribe is what? Yes and no. Yes and no. Then you realize that this equation is wrong. Then you want to modify the equation. So subscribe is giving yes or no. So I will not take the subscribe. I will convert that yes or no into number. I'll convert yes or no into number. So that's why you provided the probability of subscribe. What you provided? Probability of subscribe. So generally the classification problem is coming like this. Now you see here. In the classification problem, suppose we have two labels. One is S label and another one is the no label. S label and no label. When you pass a test input to the model, test input to the model, it will give the predictions. Predictions either yes or no. Correct? Either yes or no. But before providing yes or no, before provide yes or no, first the model will give probability values for yes case and no case. Which means what is the chance to get output as yes? That is nothing but probability of yes. And similarly, what is the chance to get the output as no? What is the chance to get output as no? That is called probability of no. So this is happened internally. Like means, now you see here. This is very, very important to understand, ma. You develop the ML model. So this is ML model. Think like that. This is the ML model. This is some ML model. ML classification model. Which model? ML classification model. Now you pass the input. You pass what you are passing? Input. You'll pass the input. Which input? Test input. You'll pass the test data. You'll pass the test sample. Some sample you are passing. Test input you are passing. When you are passing the input, it will give direct answers either yes or no. You will see the direct answer here. What you will see? Either yes you will see or no you will see. Only one you will see. Correct? But before that, there is one more block will happen. In this block, it will give the two probabilities for yes case and another one is the no case. What is the probability of yes? For this test input, what is the chance of occurring of yes? The probability. P of y it will give. And what it will give? P of no it will give. Suppose for this case, P of S is equal to 0.6 and P of no is equal to 0.4 and the final answer you will see as yes. You will pass this, you will see this, but this is happened internally. For every case. For suppose next input, you will get 0.4 here, and you will get 0.6 here. Then what is the output you will see? No case you will see. So this is called, we call logits. What we call is called logits. This is called logits. This is happened internally. That you need to understand that. Everyone is clear? Can you please confirm the chat? Yeah. Now you see here that will be written. Classification problem has two labels. Suppose assume that yes and no. When you pass the test input, it will give the predictions either yes or no. Before provide yes or no, First, the model will give the probability values for yes and no case. What is the chance of get output as yes? That is P of yes. What is the chance of that is equal to no? That is equal to P of. So here you take the second equation. That's why I like this. This is the second equation. So I'm writing that first equation. So first equation is equal to, you have written subscription. Subscribe. This is the first equation you have written. This is the first equation. This is the drawback is there. And you modify the equation into second like this. This is the second equation. Now tell me, what is the problem with second equation? What is the problem with second equation? What is the problem with first equation? Categorical comparing with numerical. What is the second equation? So here categorical is there. That's why you use your brain. You convert it into probability. Okay, before probabilities I will get. I will use the probability then. Then both are numerical only. You're comparing both are numerical only. But what is the problem? What is the problem? What is the range of LHS? What is the range of RHS? Which one 0 to 1? What is the range of RHS? What is the range of RHS? RHS can be any value, right? So it is never equal to 0 to 1. So that is the problem here. That is the problem. It is a linear equation. It is a linear equation, which means your line is like this. It is a linear equation. Line is going like this. So the line is like this. It's going like this. Now this is your equation, RHS equation. This is the RHS equation. That is called regression equation, correct? But your LHS probability values is probability is going to what? Where to where? 0 to 1 only. 0 to 1. 0 to 1 only. 0 to 1. Not only that, you might get the positive values more than 1, and you might get the negative values also for the regression equation. Yes or no? You might get the regression. This RHS equation, understood that. Suppose beta naught, beta 1 age values, you got something. Based on the data you got beta naught equal to suppose some 0.5 and beta 1 is equal to suppose 0.2 and age is equal, this is the equation, age is equal to 30. What is the answer? 0.5 plus 0. Only 6, only 6 point. Answer is equal to 6.5. Then this is the 6.5. Now this is the RHS. RHS is equal to 6.5. But probability of subscription is minimum value is how much? This minimum value equal to 0 and maximum value equal to 1. It is ranges only 0 to 1. So that is the problem. That is the drawback. That is the drawback. So your values never be equal to between 0 and 1. The values never be equal to 0 and 1. LHS equation. LHS range is LHS range between 0 to 1, but RHS ranges minus infinity to infinity. RHS range between minus infinity to plus infinity. Plus infinity. So that is the problem with second equation. So you need to think like that. I know I have studied the textbooks, then I directly attack. That is not the case. You learned linear regression yesterday. Based on that, you applied your logic is failed. Why it is failed? You are comparing numbers with categorical. Then you converted categorical with probability value. Then your logic again failed. Why it is failed? Because linear regression equation is a bar line, that means minus infinity to infinity, but your probability values are between 0 to 1. So that is the case here. So I'll write this diagram also. Now I'm just write like this. Now this line going like this is the regression equation. This is the probability P, probability of subscription, and this is your regression equation, beta naught plus beta 1 into h. So it is the 1 is the maximum and 0 is the minimum here. Then you are thinking that, yes, that is correct, sir. So I have one more idea I am getting. Whatever more than is 1 is getting. Okay. I will get into make into 1. Whatever the 0 is coming, I'll make as 0. How come this idea? That is the idea. Next idea. That is the next idea. You said that it is getting that more than 1. It is only 0 to 1 range. So whatever is getting that more than 1, I will make as 1 only. Whatever the less than 0, I will make as 0 only. This is the idea. Now, which mathematics will give that idea? Which mathematics will give that? Getting my point? What I'm saying? Now you want to do that. This part. This part and this. That is the idea. Which means this equal to is going like this. See, it is going like this, and it will convert like this, convert like this. The line become now is converted into S type. See, the straight line will convert into, we are cutting two parts. This part is going to here, this part is stopped to here. Now it look like what? Yes. Look like to? Yes. What is the mathematics equation? We'll convert this line to this line. So that mathematics we need to find out here. Understood now? Getting logic? Because you know that probability ranges between 1 to 0. That's why more than 1 we are converting to what? We are flooring to 1, and less than 0 we are flooring to 0. So the straight line is equal to, now the equation will be equal to is a kind of S curve like this. The kind of S curve. That is the idea. So that is the idea. Now we'll write that. The same thing is. Now you want to get that equation, same equation like this. Like this. Like this. This is S equation. It is the S equation. So this is one more diagram. And that name is called sigmoid function. What the name is called? Sigmoid function. Sigmoid function. Sigmoid functions values ranges between 0 to 1 only. Sigmoid function values ranges between 0 to 1. Sigmoid function. Sigmoid. Sigmoid of Z, it will note down like this. Sigma of Z is equal to 1 by 1 plus e power minus Z. E power minus Z. We want to write X, this is called sigmoid. Sigmoid of Z. We want to write in the X term, it is the X, sigmoid of X. That is called sigma of X, like this, X. The sigmoid graph is look like S. Sigmoid graph. Sigmoid, very, very famous function in deep learning as well as in machine learning. Sigmoid function. The sigmoid function look like. So we have having equation. What we have having equation? Again, listen very carefully. Why we are doing like this? I'm repeating again. This second equation. This second equation. This second equation. Now this second equation having LHS is equal to 0 to 1 range, RHS equal to minus infinity to infinity. So we want convert this RHS equation to 0 to 1. 0 to 1. That is our goal. So who is the conversion pointer here? Some function will convert. Some function will convert, and that function name is called sigmoid function. That function name is what? Sigmoid function. So now the final equation will be look like this. Probability of subscribe equal to sigmoid of, you want to convert that equation, right? Sigmoid of beta naught plus beta 1 into h. This is the equation. This is called equation number 3. The equation number 3. So where we started and where we ended, that you will understand now. So first equation equal to simply subscribe equal to subscribe equal to beta naught plus beta 1 into h. That is the equation number 1. And second equation equal to Probability of subscribe equal to, that is beta naught plus beta 1 into h. That's the second equation. And the third equation, now we have probability of subscribe equal to, this is the third equation. This is the third equation. Probability of subscribe equal to sigmoid of beta naught plus beta 1 into h. First one is numerical, categorical, don't comparable. Second one is the LHS is equal to 0 to 1 range, RHS equal to minus infinity infinity. That's why you are concentrating on this and you are converting these values ranges. It is like a jet standardization. Have you remember? What we have done, jet standardization, original value we are converted into some another value. Minus 3 to 3. Normalization, original value we are converted into 0 to 1. In the same way, sigmoid function is also beta naught plus beta 1h. It will convert into 0 to 1 and it is a non-linear behavior. That means the linear will convert into non-linear. Linear will convert into non-linear and this is the formula. What is the formula? Tell me. 1 by 1 plus e power minus x. You need to remember this. This is the utmost priority. In data science algorithm, sigmoid function equation is the one of the topest equation. 1 by 1 plus e power minus x. You should not forget this equation. It is the one top 5 equations. If you name it, this is the one. 1 by 1 plus e power minus x. E power minus x. Now, what is the sigmoid function is there here now? It is sigmoid of x equal to, it will look like this, right? It will look like this. Now tell me, what is the final equation now? How the equation will be now turn out into? P of subscribe equal to 1 by 1 by 1 plus e to the power of minus x. And this, instead of x, now what is there now? Name it that. Very good. Now this beta naught plus beta 1 into h, that will write here. Beta naught plus, I will let put bracket also, h. In the bracket here, the bracket here. That means that regression equation you are applying on the e power minus x here. So finally, the equation look like this. The equation look like P of y. P of y is equal to into x1 plus beta 2 into x2 and so on, beta n into xn. It is look like this. So this is your final equation. Probability of y is equal to 1 by e minus beta naught beta 1 x1 beta 2 x2. That means this value. So you have a data will be there. You have a data will be there. And the data, if you find out this value will ranges from 0 to 1. Everyone understood this formula now? Can you please confirm the chat? P of y is equal to 1 by 1 plus e power of minus beta naught plus beta 1 x1, beta 2 x2 and so on, beta n xn. So where we started and where we ended up is very, very important. Again, how many probabilities will be are there in our use case? How many probabilities will be there? For how many labels are there? That many probabilities, correct? Generally, classification problem, we have by classification and multi-classification will be available. Okay? Classification problem, classification problems, either by classifications Biclassification and multi-classification. Multi-classification. So biclassification means output to target variable has how many labels? Target variable has two labels. Two labels. For example, yes or no. Yes or no. So the probability also you will get like this. Probability of y is equal to s is one case. Probability of y is equal to s is another case, one case, and probability of no is the another case. Probability of y equal to no. Now you will compare P of y equal to yes and P of y equal to no, and you will get the final output. That means data is this only. X1 have a data, X2 have a data, X3 have a data, variable is there. You will calculate the regression equation. You will find on the 1 plus e power minus x formula, and then you will get one value. Then you will get one value. So this is the things generally will happen. Any doubts in this? Any doubts? Tell me. Probability will not come same. Probability will not come same. That is why you already learned the patterns right here. So you are thinking like that. The coefficient values are equal. The coefficient values are equal. The LHS. Probability of yes case and probability of no case. Two cases. Hmm. Hmm. No. 1 by 2, correct. That is the chance of that head or tail. Suppose you think like this. Suppose you are saying head, probability of getting head is equal to 0.5 you are getting. That is the probability. That is the same way probability of getting tail is the 0.5. That is your case. But this probability we are getting from where? If we are not define the probabilities, we are getting the probability from RHS equation. This value, how much is this value? That is the probability. Suppose this value is equal to you are getting 0.7. That value will differ. You are defining here. This is defining your which one? Sir, head is equal to 0.5, tail is equal to 0.5, you are defining. But how you are getting 0.5, how you are getting 0.5 value? The value is provided by this equation. The equation will provide the value. Don't think like this. There are two cases are there. That's why I'm getting 50-50 chance. That is not the case here. Here you are getting the value from RHS. How much this value is getting? That is the probability. Maybe that is a 0.2. Maybe that is a 0.1. Maybe that is a 0.9. That is. So sigmoid function will conversion all the values into 0 to 1 range. So why we are going for sigmoid function mainly? Because this values ranges to minus infinity to infinity. We want to convert it into 0 to 1. So that's why this function is giving. Now if you see here sigmoid function, we'll talk about the little bit about sigmoid function. What is x equal to 0? Tell me, what is x equal to 0? Case 1. So case 1 we will keep that as do it everyone. Case 1 x equal to 0, x equal to 0, then sigmoid of x, all this will become how much? 0, 0, 0. That is equal to 1 by 2. 1 by 2, that is equal to 0.5. 5. Now case 2, x equal to minus infinity. Case 2, x equal to minus infinity. Minus infinity. Minus infinity. E power minus infinity कितना? And case 3, plus infinity. Plus infinity. Plus infinity. Plus infinity. Plus infinity. E power infinity. This become 0. It is 1 plus 0. That become 1. And this e power minus infinity. Which one reverse? Minus. Minus infinity, this is plus. Okay. And this is minus. E power minus infinity, e power plus infinity. So this value, when x is equal to infinity side, you will get sigmoid equal to 0, like this. So with that, you see here, so it will come like this, like this, like this. Slowly it will touch this point, okay? And it will go to here, it will go to here, it will settle like this. That means this point you are seeing is called, it is maximum value is equal to 1. Maximum value is equal to how much? 1. This value is, when it touches it is 0. It is 0. That means minus infinity. When x is equal to minus infinity, the curve touches what? 0. The curve touches 0. When it is plus infinity, the curve touches to 1. The curve touches to 1. When it is 0, the curve touches to midpoint. That is called 0.5. Okay. When it is x equal to minus infinity, the curve touches to 0. When it is plus infinity, the curve touches to 1. When it is 0, that is nothing but 0.5. So x is equal to minus infinity. So x is equal to minus infinity, the curve touches what? Now it is 0. It is 0. It is 0 means you need to take like this now. Okay. 1 by 1 plus e power minus x is equal to e power x by 1 plus e power x. You getting what I'm saying? This is equal to, both are same. Okay, I will write the proof. You can just note down that. Let's come to here. Before come to, I will write here this one. 1 by 1 plus e power x is equal to, the next line you will write like this. This part is equal to again 1 by e power x. This part we can write 1 by 1 by. Like this. And then again this e power x, this part, next part, it will become equal to like this. It become like this. 1 plus only denominator, concentrate only denominator, it will become e power x plus plus 1 divided by e power x. e power x, this part. This part, okay, write like this. This will go to numerator, it will get like this. So this part 1 by 1 plus e power minus x now equal to what? Is equal to e power x by e power x and divided by 1 plus e power x. This is the both are same. Okay, note on that. And that you can apply here. The same thing you can apply here. Now you'll get your answer. You note on this first. Okay, 1 by 1 plus e power minus x equal to e power x by. Now if you apply infinity, apply the minus infinity on this. Apply the minus infinity on this. Then this become now e power minus infinity. That is e power minus infinity is nothing but 0. E power minus infinity is nothing but value is equal to how much ma? 0. So it is nothing but 0 by 1 plus 0 again. 0 by 1 plus 0. And finally, what is the answer now? 0. E power minus infinity by 1 plus e power minus x, right? The same thing. And in the same way here, plus infinity that you can take the same thing. Same you substitute. Same you substitute here. I will write in detail. And this, the next. Minus infinity and minus infinity. The same way here. Plus infinity, e power plus infinity. E power plus infinity, 1 plus e power plus infinity. So e power minus infinity, this is not required for you generally for e power minus infinity calculation, and directly this calculation will enough. Directly this calculation will give this. What ma? Like I will tell you that. Let me complete this. Now देखो एक बार. First of all, this you understood? Huh? What is the second one here? Minus infinity. Minus infinity means e power minus infinity by 1 plus e power minus infinity. Okay. E power infinity minus infinity how much? That is 0. That is equal to 0 by 1 plus 0, it is 0. That's why now we modified here. कैसे कैसे हो जाएगा? अरे you first you tell me this is valid or not? हाँ रुको. Then x कितना? ये सब्स्टिट्यूट करो ना. e पावर क्या होता? माइनस इन्फिनिटी by 1 plus e पावर क्या होता? माइनस इन्फिनिटी. Again don't reverse it. Again don't reverse it. Understood? And e पावर माइनस इन्फिनिटी कितना? 0 by 1 plus 0 कितना? 0. माइनस इन्फिनिटी है तो 0 होता. Now same come here. Plus infinity. 1 by 1 plus e पावर माइनस इन्फिनिटी. e पावर माइनस प्लस इन्फिनिटी सब्स्टिट्यूट करने तो क्या होता? माइनस इन्फिनिटी होता. हियर x जगह में इन्फिनिटी सब्स्टिट्यूट करो. व्हाट विल कम? 1 by 1 plus e power minus infinity. E power minus infinity how much? 0. 1 by 1 1. Valid. Don't reverse again. We already reversed it. We already reversed it here. Don't reverse again and don't confuse. And this will works. So now in the real line minus infinity, in the sigmoid line how much? 0. In the real line plus infinity, in the sigmoid line how much? 1. Note on this. Case 1, case 2, case 3. Case 1 is equal to x equal to 0. That is equal to 0.5. And case 2 x equal to minus infinity we want to substitute. That's why what we are taking here 1 by 1 plus e power minus x we modified into e power x by 1 plus e power x. Now substitute here x के जगह में minus infinity. When you substitute here, what will happen? E power minus infinity come here and 1 plus e power minus infinity come here. Any doubts in this? Any doubts in this? We already modified. Again, you modified. It will keep on modified only. Okay. That is because e power plus infinity, you can't write that. That is the indeterminate form, right? That's why we will target only e power minus infinity only. That's why we target only e power minus infinity. How can you convert into e power minus infinity? That's why we converted here. We didn't convert it here. Why we didn't convert it here? When you keep the plus infinity, automatically the formula will go what? E power minus infinity. And you see the diagram also. What the diagram is saying here? What the diagram saying here? Now x we have taken three things. X we have taken what? In the real axis, x we have taken minus infinity we taken, correct? X is equal to minus infinity. Next x equal to what? 0. Next x equal to what? Infinity. This is your real line. When x equal to minus infinity means sigmoid value is how much? Sigmoid value is how much? 0. When it is 0, what is sigmoid value? 0.5. 0.5. When it is infinity, what is sigmoid value? 1. Now draw the graph. Minus infinity, infinity means this is minus infinity to infinity. So minus infinity here, minus infinity here, and 0 here, and infinity here. And this is 1 here, 0.5 here, 0.5 here. And it is going, it is touching here like this, it slowly will come. It will go to here and it will go to like this. So this is called sigmoid curve. This is a sigmoid curve. Note down the sigmoid curve. Sigmoid curve is very, very important. Sigmoid formula and values. Minus infinity aito 0, x equal 0, 0.5, infinity 1. So you see infinity, what is the value? 1. Here minus infinity, what is the value? 0. Here 0, what is the value? 0.5. And this is the look like of sigmoid function. Very, very important in deep learning also. Very, very important. So what is the formula of sigmoid function? Tell me. 1 by 1 plus e power minus x. What are the values ranges between 0 to 1? That's all. 0 to 1. And what is your final equation look like? Tell me. What is your equation? What is your equation? Tell me equation. This is the equation. This is the equation. The logistic regression. That's why we called it's called regression term is there. See, we are using the regression formula. That's why, but we are making into classification. That's why logistic regression or regression term is there, right? Because we are using which formula? Regression formula. This is your final formula. You need to explain this in interview. They will ask you what is the logistic regression formula means. Probability of output target variable y equal to sigmoid of regression equation. Sigmoid of regression equation. That you need to explain. This one is the regression equation. This entire is nothing but a logistic regression equation. The small case, in simple way, we can say like this, P of y equal to, in simple way, we are writing P of y equal to beta naught plus beta 1 into x1. Like this, we are writing in simple way. In simple way, right? In simple way. Tell me in this, beta naught plus beta 1 is equal to, suppose y is equal to beta naught plus beta 1. This is a simple linear regression equation, correct? It is a linear regression equation. It is a simple linear regression. What is the interpretation of B1 here? What is the interpretation of B1? What is interpretation? Tell me. If you doesn't say, I will kill you now. Tell me. If beta 1, no, interpretation of beta 1 I'm asking. I am only listening if, after that I am not understanding. Tell me. Only Arun is saying answer. Venki, tell me. If beta 1, you will increase beta 1. If x is increased by 1 unit, y is increased by beta 1 time. That is the interpretation, correct? Understood? Now tell me the interpretation of this equation. Tell me about interpretation of this equation. How can you interpret beta 1 here? Interpret beta 1 from this equation. You can able to interpret equation by using this. Okay, this you are able to do. And what about that? What about this interpretation of beta 1? Tell me, how can you do that? Follow. What is the interpretation of beta 1 here? This is also formula, right? It is also formula. In this formula, you are able to interpret beta 1. In this formula also, you need to be able to interpret beta 1. You can't interpret this equation. Why? At least tell me that. You can't interpret that. It is a which equation? Linear equation or non-linear equation? I told you that non-linear equations can't interpret. Linear equations only can be interpreted. This is a very, very important interview question. Okay. I still remember my professor asked me this question, why interpretation is this? I am the only person explaining the answer in the class at the time. He scold left and right all the students. He given left and right. Only linear equations can be interpretable. Non-linear equations we can't interpret. Non-linear equation can't interpret. Can't interpret. So sigmoid function is a nonlinear equation. Sigmoid function is nonlinear equation. Sigmoid function is a nonlinear equation. So we can't interpret that. We can't interpret. We can't interpret. We can't interpret. So that's why to make interpretation, we'll convert this equation linear, nonlinear to linear now. This is. So for simple term, we'll give as this P and this as X. This as P and this as X. Okay, for simple term. Now that P into this term, this is 1. Next, P into 1 P. This is also P into. This is P. And next, P into e power minus x equal to 1 minus P. And e power minus x equal to 1 minus P divided by P. Then e power x equal to P by 1 minus P. P by 1 minus P. Then x equal to logarithm of P by 1 minus P. Then what is x? X is nothing but equation. Then this equal to log of this equation. If you not understand, I will explain. Don't worry. Just reverse it. Log of P by 1 minus P equal to beta naught plus beta 1x. Is the equation number 4. Not on this first. Easy, ma. Easy. That easy modification. Nothing is there in that. Easy modification in that. P is equal to 1 by 1 plus e power minus x. Next, what we have taken? p into 1 plus e power minus x is equal to 1. P into 1, p. P into e power minus x, p into e power minus x is equal to 1. Then what you have taken? This p, you taken this RHS side, 1 minus p. Then p, this p becomes like this, 1 minus p by p. E power minus x is equal to numerator by denominator. If you remove this minus x to positive x, it will be up p by 1 minus p. This is the mathematics logic it is. If you want, you can do again modify like this. You convert into e power minus x equal to 1 by e power x. Then cross multiplication karo. Automatically what happen? It will be numerator will be denominator, denominator will be numerator. And then e either so it will go to this side, then it will become what? Log. It will become log. That is also mathematics. X equal to log of. This e. If you want to take this e from this side to this side, then it will become what? Log. Then x equal to what? You assume. So you confuse x is equal, then assume that, okay. You might be confused again if I take x. I will take what? Assume that this is k. Assume that this entire equation is what? K equal to. Then it is k. It is k. The మొత్తం టీతోనే మొత్తం నింపిస్తున్నారు నరేష్ రెడ్డి వాళ్ళు. k. This is k. And this is k. K is equal to, we replace what this, then this is the final answer. Understood? Any doubts in this? I'm not teaching this all this for time pass, ma. These all are very, very important when you explain in interview. Okay. Studying only logistic regression equation. First equation is equal to p of y by 1 plus 1 by e power minus x. Then second equation is equal to log of p by 1 minus p. I will study only two equation. I will go for interview means I will kick out you. Okay. Only two equations, na? That is logistic regression. What is the one equation? This is the one equation. And this is the another equation. Now the beauty you see here, it become now y equal to beta naught plus beta 1 and x1. Now it is equal to, now it become what? Linear equation. It become a linear equation. Now interpret this. How can you interpret this? If we say that both, if we increase, x by 1 unit, then what? That is not y, no. What is that? Log odds ratio. What is the name is called? Log odds ratio. P is the 1p, 1 minus p. Both are odd or even? Odd. Odd means not that odd or even. English meaning में वो odd समझ है ना? English में odd. Odds ratio. Both are ratio na? And what is there? Logarithm. So it is called log odds ratio. Write that log odds ratio. The term is called here. This term is called log odds ratio. So if we increase x by 1 unit, then log odds ratio will be increased by beta 1 times. That is the interpretation, the logistic regression. That's why the name is called what? Logistic regression. The log hai naam, and here regression. That's why this name is called logistic regression. So equation number 1, we started with this. Equation number 1, we started with this. And equation 3, this is the equation 3. The equation 3. And this is the equation number. Equation number 3, equation number 4 only that generally there in the textbook. Equation 1 and equation 2 to make you to understand why we are going like this. Why we are going to classification program, that we are using this. You need to explain logistic regression. Equation 3 and equation 4 is a very, very important one. To get equation 3, we required what? Required what? Huh? X, fix sigmoid. To get equation 3, we need sigmoid function. So you need to explain in interview about sigmoid function. Why we are going for equation 4? We are not able to interpret equation 3. Okay? We are not able to interpret equation 3. That's why we modified into equation 4. We modified to equation 4. So you need to learn equation 3, sigmoid function, modification mathematics, and finally settle with equation 4. So you need to start with equation 3 directly, okay? Start with directly equation 3. Start with sigmoid function. And land up equation 3. Okay, that is the first step. And then learn modification mathematics, maths, and then land up to equation 4. Then logistic regression will be completed. Okay, so that is today's assignment. Start with sigmoid function and land up with equation 3. Then write that I am not able to interpret because it is a non-linear equation. So write the mathematics and land up to equation 4. That is then logistic regression is completed. And the same, whatever you find in the coefficient, that story is same again. We already done in linear regression, right? The same story applicable here. Because you are using which equation here? Linear equations. The same story will come here. If you see, we'll go to the PPT ones. We'll go to the PPT ones. Logistic regression. Just look at the PPT now. So it is a tumor size versus tumor type. One problem. So benign and malignant, those are the tumor types. So malignant means if the tumor is more, benign means tumor is less. So this is a data set look like tumor size. Based on the tumor size, it is a tumor type. 0 means what is the tumor type? Benign. 1 means what is that? Malignant. Now what is the problem here? Same problem. Linear regression curve. More than, greater than 1 and less than 0. And then there are some I've given some of 1.2 what happened like that I have given, that is you no need to worry. But that is next what you need to do, you need to convert it into RSS. That is nothing but probability of getting tumor equal to 1, which means S case, probability of getting no case. Then next, what is the formula? 1 by 1 plus e power minus z. Here z is equal to what? A plus into bx. Then what is the formula? Logistic regression model equal to 1 by 1 plus e power minus a plus bx. This is the equation number what? 3. Equation number 3. And then this is the range minus infinity to infinity. And this is the range of 0 to 1. It is a linear, that is general model, linear model. Okay. And is a logistic model, that is sigmoid function. And minus infinity converted into what? 0. Plus infinity converted into what? 1. And then logistic regression model is equal to like this. Probability of getting success. Y equal to 1 means he is concentrating only on the success. 1 by 1 plus e power minus regression equation. This entire thing is called which function? Non-linear function. So non-linear function, say minus infinity, infinity, and plus infinity, that. And that linear transformation. This linear transformation is mathematics, just now we converted. Non-linear transformation to linear transformation mathematics. And finally, we'll get p by log of 1 minus p is equal to a plus b. And this is called what? Log odds ratio. And that is called interpretation. And odds ratio, odds means what is the meaning of odds? One is success by, another one is the failure. Odd, success and fail. Both are complete opposite each other. And this is the entire workflow. Tell me the workflow now. First, what will happen? Training data. Next, what will happen? Model. Next, what happen? Probabilities. Finally, what happen? Classes. So classification model will work like this. Okay, look at that 30 seconds on this. First training data, and then from the training data you will get that model. Here logistic regression model, but in future any model, that is any model. After that what happen? It will predict the S class for 1 and as well as 0. You will get only for 1, automatically that 1 minus p what will get? 0 case. You will get 0 case. And similarly finally you will get final class. And this is the problem number 1, estimate of A and B. Estimate of A and B, and this is the problem number 2 and problem number 3. First, finding the model is the one problem, and second, getting the probabilities, and last one is getting the final output. 3 problems. What is the problem number 1? Creating the model. Creating the model. Second one is what? Getting the predictions. Predictions in terms of what? Probabilities. And finally, final output, where it is yes or no. Always remember, in Python, you will get the value directly yes or no only. But in the backend, what will happen? It will provide the probabilities. What is the name is called? Logits. Don't forget that. Logits. Logits or logits. And derive the probability from odds. That is same story, reverse. It is a reverse engineering. It is a reverse engineering. Same story. So classified 1, classified 2, why we need probabilities? Probabilities are very, very important. This is not required, that you already know, that is greater than 0.5, some threshold. The threshold might be 0.5, the threshold might be 0.6, that is based on our company discussion, that is. But default it will take 0.5 only, the threshold. And then these are the metrics. Metrics I will teach at one place. All once completed the models, I will teach the metric. This is called logistic regression model. Very, very famous in the bank use cases. Bank use cases. And very, very famous for by classification methods. By classification methods, people will blindly use logistic regression now. And logistic, if you understand the linear regression, then logistic regression is very easy now. Are you feeling that? It is nothing, it's very simple maths, right? Compared to that. So one-time practice is required. One-time practice is required. If you want to explain that any classification model interview, choose the logistic regression. That is easy and you can play with maths. You can explain that. First, step 3. To go to step 3, equation 3. sigmoid function. Sigmoid function you can able to explain easily. Then after the sigmoid function, you are what you will say that I am not able to interpret, sir. That's why I will convert it into linear transformation. This is my mathematics. You can explain that. Then definitely the other person will be feel very happy. And if you want to ask any questions, again that is related to linear regression only. That is how can you find the coefficients? I will use wireless method. What are the assumptions? You will tell that assumptions. So if you understand linear and logistic, then you can easily crack that interview mark. That is logistic regression is very important and good mathematics is there in this. And the main thing is called sigmoid function. Sigmoid activation function is there. That is very, very important in deep learning. Activation functions. There's the concept is there. Activation functions in neural network. Okay. In this one activation function name is called sigmoid. Again, when we learn deep learning, again this concept will come. Which concept? Sigmoid activation function. So sigmoid is a non-linearity. Non-linearity. Non-linearity means think like that. Imagine your human brain. The human brain has what happened? Many neurons. So many neurons, zigzag neurons, right? It is not like the sequential. One neuron after one neuron will not there. It is a zigzag manner. The zigzag manner is nothing but non-linearity. Straightforward, nothing but linearity. That mathematics, that neurons will converted here. That's why the non-linear functions are very, very important. In that one good non-linear function is sigmoid activation function. Okay? So today I will create the assignment for this write up. You need to finish as soon as possible. Chalo ma. Thank you. Thank you so much. Can you please confirm the chat, ma? Good, right? Today you people are not responded in the chat. Yeah. Thank you. Huh. వేరియంట్ ఎర్రర్స్ ఉన్నాయి కదా ఎర్రర్స్ కి ప్లాట్ చేయాలి ఎర్రర్స్ కి ప్లాట్ చేయాలి ఎర్రర్స్ కి డిస్ట్రిబ్యూషన్ ప్లాట్ చేయాలి అబ్జర్వేషన్స్ అంటే అక్కడ మన సినారియోలో అక్కడ వచ్చేసి ఎర్రర్స్ కి మనం ప్లాట్ చేయాలి ప్లాట్ చేసి ఆ డయాగ్రామ్ ఎలా వస్తుందో ఆ డయాగ్రామ్ ఆల్మోస్ట్ అన్ని వర్డ్స్ కూడా సేమ్ లుక్ లైక్ ఉంటుంది డేటా అనేది సేమ్ ఉంటుంది సేమ్ స్ప్రెడ్ సేమ్ ఉంటుంది డేటా సేమ్ ఉండదు స్ప్రెడ్ గ్రాఫ్ చూడడానికి గ్రాఫ్ చూడడానికి సేమ్ ఉంటుంది అంటే హోమో ప్రాబిలిటీస్ ఎక్కువ దానికి అనుకోవాలి సార్ ఎక్కువ